Next, define an iMachining 3D operation to perform the rough machining. In simulation afterwards, you'll see that iMachining 3D automatically uses the hole from the previous operation for entry. In the SolidCAM Manager, right-click the operations header and choose 3D iMachining from the Add Milling Operations submenu. The iMachining operation dialog box is displayed. On the geometry page, you can see that target appears in the geometry name field, meaning that the solid model of the target is automatically selected for the machining geometry. In the Working Area section, click the Define button. The Working Area dialog box is displayed. Click the Show 3D button in the Cut Only the Rest Material section. Because iMachining 3D works in this mode by default, you can see that the updated stock model from the previous drilling operation is utilized as input for the starting stock model of the current operation. Click the Exit button to close the Solid Verify simulation window, and then click OK to close the Working Area dialog box. At this stage, the geometry is automatically defined. Next, switch to the Tool page and click the Select button. In the Part Tool table, select Tool number 2, the 9.5mm end mill with 24mm cutting length and 4 flutes. By switching to the iData tab, you'll see that this tool also has a 45-degree helical angle. These tool parameters will affect the cutting conditions generated by the Technology Wizard. Click the Select button to choose the tool for the operation and exit the Part Tool table. Next, switch to the Levels page to define the milling levels. Click the Upper Level button. In the SOLIDWORKS graphics area, pick on the top face of the stock model as shown. Then, click OK to confirm the selection. Click the Lower Level button. In the SOLIDWORKS graphics area, pick on the bottom edge of the target model as shown. Then, click OK to confirm the selection. Next, switch to the Technology Wizard page to choose a calculated set of cutting conditions. For this operation, use the default cutting conditions generated by the wizard with a machining level aggressiveness of 6. Looking at the step-down output grid, the wizard automatically calculated one step to achieve the maximum depth. The ACP indication at that depth is 3.2, and the field is painted green for good stability. Looking at the output cutting data, you can view the two sets of data related to the current cutting condition: the spin and feed rate of the tool, the step-over range, the material cutting speed, etc. At this stage, the tool, milling levels, and cutting conditions are defined for the operation. Next, switch to the Technology page to define the technological parameters. In the Passes area, leave the default settings. In the Offsets area, enter a value of 0.24mm for the surface and wall offset parameter. Next, switch to the Link page. In this case, the helical entry settings do not apply since the tool will feed down into the entry hole provided by the previous drilling operation. At this point, the operation can be calculated and the toolpath can be viewed on the model. Click the Save and Calculate button to add the iMachining 3D operation to the CAM tree and calculate the toolpath. After the calculation is completed, click the Simulate button to display the simulation control panel. Switch to the Solid Verify tab, and then click the operations header in the SolidCAM Manager so that the simulation will run in its entirety. Select your desired simulation speed using the slider, and then click the Operation Step Mode button to play the simulation for the first operation. The tool approaches and performs drilling in the location of the through hole. Click the Operation Step Mode button again to play the simulation for the iMachining 3D operation. The next tool approaches and feeds down into the pre-drilled hole, using it for safe tool entry. Starting with the through hole and stepping up to the appropriate Z levels, the tool then performs machining of the pockets and islands. At the end of simulation, the tool performs the rough machining of the outside shape. At this stage, step 2 is complete. Without having to chain or sketch a single contour, the roughing and rest roughing of this entire prismatic part is defined with a single iMachining 3D operation. Using the Exit button, close the Simulation Control Panel. If you have not followed along, apply and practice the procedures shown in this video to define a pre-drilling operation as well as an iMachining 3D operation to perform the rough machining of the prismatic part.